Hello and welcome. In this video, we're going to solve this problem right here. The tension in the horizontal cord in this diagram is 30 Newton. This is the horizontal cord right here, and this is the force 30 Newton, or the tension 30 Newton. We are told to find the weight of this object. Okay, so how do we find the weight of this object? Firstly, let's draw the free body diagram. Alright, so right here we have 30 Newton, and here we have angle 50 degrees. Here we have angle 40 degrees, and then the weight of the object acting downwards. Okay, so this is angle 90, right angle. So if this is 50, this is going to be 40 degrees. Alright, so now in order to solve this problem, we have to remember our conditions of equilibrium. An object is in equilibrium under the action of concurrent forces if it is not accelerating, right? Acceleration is 0. 2. The summation of all the forces acting on the body is 0. And 3. The summation of forces in the x direction is 0. The summation of forces in the y direction in the y direction and the summation of forces in the z direction equate to 0. Okay, so in this case, this is what we're going to be making use of, because we have this component x direction, y direction, and z direction. Alright, so what is the summation of the forces in the x direction? The summation of forces in the x direction must be 0. So what are the forces in the x direction? We have 30 Newton. Okay, now we have a force here. Let's call this force the force for cord 2. Let's call it F2. Okay, the force for cord 1, that is equal to the weight of the object. So W is equal to F1. Alright, so we have an angle 40 degrees, so we have to resolve F2 to the horizontal. Okay, so when we resolve F2 to the horizontal, we are going to have F2 cos 40 degrees. And when we resolve F2 to the vertical, we are going to have F2 sine 40 degrees. I've made a video explaining how we have cos 40, how we have cos and sine, basically how to get it. So I'm going to leave that in the description. I'm going to leave some videos in the description for you to check out. Alright, so let's move on. Okay, so what are the forces in the x direction? We have 30 Newton, and we also have F2 cos 40. Okay, so 30 Newton is acting in the positive x direction, and for F2 cos 40 is acting in the negative x direction. Okay, so the summation of the forces in the x direction will be 30, right, plus 30 because it's acting in the positive, and then the one in the negative direction becomes minus, right, F2 cos 40, and that is equal to 0. Okay, so 30 equals to F2 cos 40, and F2 will be equal to 30 divided by cos 40. And when we type that in our calculator, what do we have? 39.2 Newton approximately. Alright, now the summation of forces in the y direction must be equal to 0. Okay, alright, so I see I made a mistake here. This should be the y direction, and this should be the x direction. Okay, we're on track. We're still on track, right? Yes, we're still on track. Alright, so the summation of forces in the y direction, we have our weight in the y direction. We also have F2 sine 40 in the y direction as well. So this is in the positive y direction, this is in the negative y direction. So F2 sine 40, that's going to be positive. F2 sine 40. Then the negative, which is our weight, minus weight, is equal to 0. So our weight is equal to F2 sine 40. Alright, so weight will be equal to 39.2 multiplied by sine 40. When we type that in our calculator, what do we have? We have approximately 25 Newton. And that is it. That's the answer to the question. Alright, I hope you learned something. Don't forget to like, share, subscribe, and drop a comment if you have any questions. See you in the next video where we solve more problems on equilibrium under concurrent forces.